Manly VariMu. Can work as a compressor or a limiter. I've had it for 10 years and I've only ever used it as a compressor. And you're probably asking why. And to be honest, it's for lack of not knowing how to use it as a limiter. A lot of people have said digital limiters are better, and I've always used digital limiters and gotten a good result out of them. But it leaves me begging the question to answer, why buy an analog limiter? I didn't buy this for the limiting, I bought it for the compression, but still, $7,000 of limiting, and other people spend 5, 6, 7, 10 grand on analog limiters that sound great. Well, I can't say they sound great, but people justify that money because they think it sounds great. But does it? Now, I want to, feed my curiosity here. We're going to deep dive and make a direct comparison between this VariMu limiter and a digital limiter. I want to cite similarities in the design, differences, listen to a sonic comparison, and I want to use that information all together to objectively inform us, and maybe even look at how maybe I can modify my workflow using an analog limiter to create a best use case for this, to get the most out of it. I really hope this works out. So, what's similar between an analog limiter and a digital limiter? Well, they both carry a signal, and when the high-level information of that signal exceeds a certain amplitude, they reduce the gain to an infinity to 1 ratio. Now, that's about where the similarities start and end, because there are actually quite a few differences between an analog limiter and a digital one. Let's start off with the detection for the control signal. Analog signals are continuous in time and amplitude. There are no discrete values, so there's always a constant current passing through the detection circuit, which in theory allows for more accurate and stable gain control. You compare that to a digital signal. Digital signals are discrete both in amplitude and time, which in theory allows for errors to be made in the detection module of a digital limiter. At 44.1 kHz, this discrepancy between the discrete sample peak and the waveform's true peak value can be up to 3 decibels full scale. Now, this is more often than not counteracted by interpolating new sample values between the existing ones, using oversampling to minimize this to within 1/10 of a decibel. And that is documented in ITU BS 1770 algorithms to measure audio program loudness and true peak audio level. The next is the difference between the topology, a feed forward or a feedback design. Now, I don't know much about either's, but I did some digging, and it's to my understanding, based on the FAQ on Manly's page for the VariMu, that it features a feedback design, whereby the gain reduction is done by making the DC bias on the input tube more negative. As more negative voltage is applied to the tube via a control signal, the more gain reduction is produced. In addition to this, with something like a VariMu, the attack and release times are limited by the sum of the charge and discharge times of the capacitors and the total resistance through the circuit. So getting a 0 millisecond instantaneous fast attack and release in a tube circuit is somewhat limited. I'd like to note there are FET-based limiters or field effect transistors, which are much more faster reacting, and that's a topic I'm planning to go into much further detail in the future. Now, digital limiters, feed forward or feedback. The DSP for a digital limiter can be set up in basically both manners, but I'd make a pretty safe assumption to say that digital limiters are feed forward, whereby they can more accurately manipulate the control signal with parameters like look-ahead, instantaneous attack, sidechain filters, and a whole bunch of other cool features. And the result of that is that they're much faster, they have a fixed ceiling and ratio, not a knee which leans into the ceiling like the VariMu does, and you can also implement unique features like clippers or other algorithms like in intelligent release control isotope has to manipulate the envelope by the way of algebraic data. Now, I've matched the curves here for way of testing, and I've also matched the identical settings I'm using here in my DAW for some tests we're going to listen to. Now, setting up this Manly VariMu is interesting. On a digital limiter, you have a ceiling, you set it, it operates at that. Whereas on the VariMu, the input and threshold have an interesting interaction. Now, the threshold is important because the more closer to maximum you have the threshold, the harder the limiting style is, which means you need to drive the input slightly hotter in order to get that sort of hard limiting style. However, if you want a softening coming into it, you have to pull the input back as well as the threshold closer towards minimum. As you go towards minimum, it has a softer curve that leans into the limiting. So you can actually change the style of the way this limiter interacts with material by manipulating the input and threshold. However, for the sake of this test, I've got the threshold set at what is documented by Manly as 9 o'clock, but it's actually 3 o'clock on the unit. At 3 o'clock, closer towards maximum, they've documented it incorrectly on their page. I'll hit them up about that because it's a bit confusing the way that's documented. So it's at 3 o'clock, technically the 9 o'clock on their graph, and the input taking as much gain reduction as the digital limiter. Now that's the sort of curve you get here, and we're going to look at this in practice. Okay, so what I've got here is a track by Morning Maxwell called Wake Me Up. I've got the loudest true peak and the loudest section or short-term LUFS section of the track marked here. The overall integrated loudest of this is 15.5 LUFS, and it's my aim to use the ozone maximizer here to do 5.5 decibels of overall threshold, so I can get up to -10 LUFS on this. That's an arbitrary number. It's not anything I follow. It's just for the sake of testing, and that's it. Now, in addition to that, I've also adjusted the ceiling at the true peak level because there are errors, there are overs with this digital limiter to make sure that it sits below 0. So I've brought the ceiling down 1.4 decibels. I could have used the true peak, but I wanted to keep it apples for apples, digital PCM limiting versus analog limiting. Now, with the analog one, I'm doing the same thing. I've got it going out of my converter into the VariMu back in, and then I'm just gain staging here to get it back up to the ceiling at the true peak level here. Now, let's have a listen to these two together at the same true peak. I haven't level matched them. I'm just using the true peak values because that is how loud this VariMu is allowing me to get, and is how loud that limiter is allowing me to get. Now, you can probably say there's about 2 to 3 decibels at any one point loudness difference between the digital and the analog. And that is because, as I said, I'm not going to go over 0 decibels. I'm going to match them to true peak. But the initial transient everything is still getting through. And I'll just show you something in Plugin Doctor. I don't know why I closed it. And what's actually happening is this. I've got the attack and release ramp here. You can see when it ramps up, it doesn't quite capture that signal. This is doing about 10 decibels of gain reduction. And that initial transient of the waveform happens to sneak through at every time. Because as I said, there's 25 milliseconds attack time. The onset of the limiting isn't instantaneous like the digital limiter. It's just allowing this little amount of peak to get through. So what I thought of doing is getting standard clip and just clipping that 3 decibels of discrepancy. So here I've got the digital limiter, but as I said, those little peaks and little overs, these little overshoots here from the analog limiter are controlling how hard I can actually drive this without distorting. So what I've done is I've added standard clip at the end, 3.5 decibel and gained up. It's only going to take the transient off, and now we can actually have a listen to both of them alongside one another. I actually did standard clip to loudness match the two. So the analog limiter through the digital clipper versus the digital limiter. This is going to be interesting. Have a listen to this because they're both pretty damn loud, but they've got two very tonal different characteristics. So we've got something now with similar loudness and two very distinct and different tones. The digital limiter we can definitely hear working. We can hear it pushing down and bringing down those transients, but the low end feels a little bit more fuller and warmer overall. The analog version feels, at least to my ear, much more snappy, much more transient based. And I also think that's a byproduct of some of the distortions the clipper is introducing to those little peaks. So as a use case, I really like this limiter if I need to keep the snap intact. I think this is going to become a tool or a system I'm going to use going into the VariMu for limiting and then clipping if I want to have a very snappy, punchy, sort of edgy and gritty transient quality to my masters. That said, another thing I found was that because, remember this curve, where was that curve? I'm going to put it up on the screen that Manly showed. Now, this curve, which I'm able to manipulate via way of the way I use my input and threshold, allows me to get a bit of a soft knee into the limiting. And what that created a byproduct here is on these softer passages, so not the choruses, and here, it helped bring up that volume, that level. So I had a loud and full volume pretty much throughout the track, almost like it was a parallel compressor just pulling up that low level detail. Take a listen to these sections, because remember, the choruses are still level matched. And even on this outro where the drums are, take a listen to this. It just snaps and hits, and I like that. Because remember, the digital ceiling, it's the ceiling, everything gets pushed down and brought down. The analog one is a soft knee into it, so it's compressing as it's getting louder at not a fixed ratio, it's variable. So what sort of observations can we make from this? You will not get as loud of a master using an analog limiter or the VariMu limiter on its own. Digital limiters, as a tool to get something loud, is going to do the job. So you don't have to stress, oh, I need an analog limiter to make loud masters. No, you can do that with a digital limiter. What I found interesting was the way I could manipulate the interaction of the limiter, especially the knee, and also pair that with the clipping. It made this for a very versatile tool for this instance where I was looking for something that was punchy and smacking. And I liked the quality of it, which is important. That was subjective. That's a subjective, not an objective observation. I like the quality of this in terms of using this limiter into a clipper. So with all that said, I'd like to know from you guys, which did you prefer, the analog or the digital limiter? I'm not going to take offense if you like the digital limiter more than the analog. That's cool. Everybody has their own taste, their own vibe, perfectly fine. But it was an interesting test I wanted to put together for you guys. Now, if you're interested about limiters and want to find out more behind the scenes of it, True Peak Limiting, IRC algorithm patent, I go through both of them in depth in these videos. Make sure to watch them. You'll absolutely enjoy them. Subscribe, and until next time, take care.